So on the last videos, I discussed the definition of mole and the relationship between mole and Avogadro's number. Now, do you still remember the last question I gave to you? Yes, I asked you about which has more mass, 1 mole of water or 1 mole of table sugar. So, in this lesson, I'm going to introduce a new quantity related to mole. But before that, okay, let me give you this question. Does a pair of socks has the same mass as a pair of gloves? So this is essentially the same question as what I gave you last time. Does 1 mole of water has the same mass as 1 mole of table sugar? So let's find out the answer. So now let us explore the relationship between molar mass and mole. But what is molar mass? So molar mass is the mass in grams per 1 mole of a substance. So as you can see in the diagram, we have 1 mole of substance being measured, and then we can determine from that amount of substance the molar mass given in grams per mole. So for an element, the molar mass is equal to its atomic mass in grams per mole. So where we can find this atomic mass? So you need a periodic table as a reference. So for instance, I have this portion of periodic table here shown to you, and for instance, you were asked to determine the molar mass of hydrogen. So what you are going to do, you have to look for the element hydrogen in the periodic table and determine its atomic mass. So nasaan po iyong atomic mass na yon? So please use the legend found in your periodic table as a guide. So in this periodic table, our atomic mass is located under the symbol, under the name of the element. So in case of hydrogen, for example, the atomic mass of hydrogen is 1.008. Okay, now what is the molar mass of hydrogen? So as stated, the molar mass of hydrogen is equal to its atomic mass expressed in grams per mole. Therefore, hydrogen has a molar mass of 1.008 grams per mole. Okay, now how about for compounds? The molar mass of compounds is the sum of the molar masses of the elements in the given chemical formula. So later on, I will give an example for this. But for the meantime, kindly look at this periodic table. So this is the periodic table from the International Union of Pure and Applied Chemistry. Okay. So we have a note here below that for the sake of our discussion and convenience in your computation, we are going to round off the atomic masses to the nearest whole numbers except for hydrogen and chlorine. So what does it mean? Gagamitin po natin na atomic mass is whole number. So for example, we have oxygen. As you can see in the periodic table, we have 15.999. So when we round it up, we will have 16. So whole number po yung gagamitin natin for atomic masses of the elements na involved sa ating problem. Except, okay, so I made an exception for hydrogen, which is gagamitin po natin yung 1.008, and for chlorine, which is 35.45. Kasi pag ni-round up natin siya or ni-round down natin siya, medyo malaki yung mawawala sa kanya. Okay? So, I hope we are clear with this. So, let's try this sample problem number 1. So, give the molar mass of the following. 1 mole of hydrogen atom, 1 mole of oxygen atom, 1 mole of phosphorus atom, and 1 mole of gold atom. So, what is the first step? Ano po ang una natin gagawin? Get your periodic table and look for the elements mentioned in the problem. Okay, so for instance, okay, we have to look for hydrogen, oxygen, phosphorus, and gold. So, I'm going to zoom in the elements involved in the problem. So, we have hydrogen, oxygen, phosphorus, and gold atoms. So, you were asked to determine the molar masses of these atoms. Now, in order for you to answer that question, the first thing na kailangan po natin gawin is to find the atomic mass of these elements. So, what is the molar mass of hydrogen, for instance? Yes, very good. We have 1.008. So, therefore, what is the molar mass of hydrogen? Okay, 1.008 grams per mole. So, don't forget the unit, okay? Because our molar mass is expressed, again, in grams per mole. So, you are correct in giving me the molar mass of hydrogen atom. How about 1 mole of oxygen atom? So, we have 16 grams per mole. Very good. How about 1 mole of phosphorus atom? So, we have 31 grams per mole. Correct. How about 1 mole of gold atom? So, we have 197 grams per mole. So, as you can see, the problem is simple. Okay, all you have to do in order for you to determine the molar mass of elements is for you to look its atomic mass in the periodic table of elements. Now, how about for compounds? Let's take sample problem number 2 as an example. What is the molar mass of water? So, the compound in the given problem is water with the chemical formula of H2O. Ngayon, ano ang unang step na dapat natin gawin in order for us to get the molar mass of H2O? So, first is you have to write the correct chemical formula of the compound given in the problem. So, for instance, given naman na si H2O, so you don't have any problem at all. So, just write H2O. Next, we have 3 basic steps in solving this problem. So, ano yung una? Number 1 is you have to determine the number of atoms contained in the given formula. So, ano ibig sabihin nun? Okay, bibilangin natin ilang atoms ba ang meron sa bawat element na present doon sa given chemical formula natin. So, ano-anong elements ba ang meron muna tayo? So, we have hydrogen and oxygen. Then, after identifying yung ating elements, bilangin na natin ilan ang atoms na present. So, for oxygen, we have 1. Okay, sir, paano po nalaman na that is 1? Okay, kapag walang nakasulat na number, it is understood that we have 1 as its subscript. Okay? Then, how about hydrogen? So, how many atoms of hydrogen we have in the chemical formula H2O? So, we have 2. Very good. Now, the second step is for you to find the atomic masses of the given elements on the periodic table. So, in the case of oxygen? What is its atomic mass? Correct. We have 16 grams per mole. How about hydrogen? We have 1.008 grams per mole. After getting the atomic masses of each element, you are going to multiply that to the number of particles. So, i-multiply lang po. And then get the product of each operations. So, we have 16 grams per mole for 1 times 16 and 2.016 for 2 times 1.008 grams per mole. Now, what is the last step? Okay, you have to add all of the molar masses ng bawat constituent elements na present doon sa ating chemical formula. Okay. So, 16 plus 2.016 is equal to 18.016 grams per mole, or you can express your answer to 18 grams per mole. Okay? So, nakuha po ba? Okay. So, let's proceed with another sample. Let's solve problem number 3. Okay, we are asked to calculate the molar mass of Na2PO4 or sodium phosphate. Okay, so we have to apply here our 3 steps. So, step number 1 is you have to determine the number of atoms contained in the given formula. And then, you have to find the atomic masses of the atoms involved and compute for the molar mass. So, let's solve the problem. Write correctly the given chemical formula, then identify the number of atoms in each of the element. So, for instance, we have oxygen, so we have 4 atoms. For phosphorus, we have 1. For sodium, we have 2. And then, look for the atomic masses of each element in the periodic table and then multiply it with the number of atoms. So, for oxygen, we have 16 grams per mole. For phosphorus, we have 31 grams per mole. And for sodium, we have 23 grams per mole. Now, compute for the product of each molar masses and then add each molar masses. So, we have 141 grams per mole. So, diba? Madali lang po. Okay, I hope you can follow me. Now, this is the mass of 1 mole of different substances. So, as you can see in the table, we have oxygen gas. So, its chemical formula is O2 and its molar mass is 32 grams per mole. It's because, okay, yung ating oxygen gas here have 2 atoms of oxygen. Okay, but the number of particles is 6.02 times 10 to the 23. Okay, molecule of oxygen. So for sucrose, okay, we have the chemical formula C12H22O11 and its molar mass, if you compute it, will be 342.18 grams per mole, and the number of particles is 6.02 times 10 to the 23 molecule of sucrose. And for sodium chloride, we have the chemical formula NaCl, and if you compute for its molar mass, that would be 58.45 grams per mole, and the number of particles is still 6.02 times 10 to the 23 formula units of NaCl. So as you can see here, okay, we have the same number of particles because we are talking here 1 mole, okay? As we previously learned, 1 mole of anything is equal to Avogadro's number, right? But the molar masses differs depending on the substance. Now, we can answer our post question at the beginning of this lesson. So, thus, 1 pair of gloves has the same mass as 1 pair of socks. So definitely they won't because they have different materials. Just like asking you if which has more mass, 1 mole of water or 1 mole of sucrose? Definitely, we will have 1 mole of sucrose. It's because sucrose is 342.18 grams per mole and our water is only 18 grams per mole. Okay. So, for you to visualize, these are other examples of 1 mole of different substances. For instance, we have some common elements, okay, that you can find and use. So, we have the first one, okay, from the back row, we have bromine here. Okay, this is bromine. Okay, and then we have aluminum. Okay, we have mercury, and we have mercury, this one, and we have copper. Okay, and then on the front we have sulfur, this yellow, and we have zinc, and we have iron. So as you can see, all of these substances have 1 mole, but they differ in molar masses. Okay? So, to end this topic, I want to leave you some question. So, does 1 mole of water has the same mass as 1 mole of sucrose?